Alrighty, so in the nature of bad ideas, here we go. This device is a test of an IGBT. So based off everything I've read, these things should behave a lot like FETs. And what I mean by that is that they should have a very, very high impedance and therefore a very, very low input current on the gate, versus a conventional IGBT where that would, or rather a conventional like bijunction transistor where that would be limited. So in turn, what I've done here is the test setup is this: is I have a 555 set up here. Should be about 20 kilohertz plus minus 10%, probably more minus than plus, admittedly. So say 15, like 18, 15 kilohertz, something like that. Just puts out a generic square wave like we always see from a 555. I have an additional IGBT. This is rather an IGBT here. Part number is H30R1103. There's a few other digits that are shorted on the chip. I'll try to put that in the comment whenever I upload the video. This is a bridge rectifier, just basic bridge rectifier. I think that this is going to be an 8 amp one. It's a GBU8K. Might be a little light duty for this. Hot plate. I did measure the DC resistance of this on high, and it is about 13.8 ohms, so I expect this to pull a little over 8 amps at 120 volts. Something worth noting about this is that this does not use a variable, it doesn't vary the current or the voltage whenever it's modulating the heat. What it does is it's a bang-bang control system where it just shuts the element on and off. And it has like a thermostatic switch in there that just click and shuts on and off. So there's that. Besides that, though, there is an electrolytic capacitor on the input side. Nothing crazy or special, just something to smooth the input up. Oh man, that would have been exciting. Let's just hit that with the iron real fast, because like that would have been just a flat out short, and like Mr. Bricker would have gotten really exciting there. Yeah. All aside though, right? So there's a few odds of what's going to happen here. The first one is that this thing is just going to explode. The electrolytic capacitor, for some reason, not zero. It'll smoke the IGBT, it'll smoke the bridge, or somehow it will smoke the 555. In terms of outlandish stuff, it might smoke my 12-volt power supply. I don't know. I got it at a Hamfest I think I got it for free at a Hamfest, oddly. So, well, it's not a big loss. It's something I've been wanting to rebuild anyways for a while, so we shall see. If you notice my light turned off, that's because I got this set up on my power strip. I guess that's another possibility, too, is that this thing's just going to trip the power strip or the breaker. So, let's see what happens. Alright, so it's definitely on. The power supply is on, so that's a good sign. I'm feeling heat off of the, I'm feeling heat, and you can see that is on. So that's all good signs. So right now, I'm definitely going through the IGBT. I'm totally, at this point, willing to consider this a success. The next phase of this would probably be, oh yeah, that's getting nice and hot. The next phase of this will probably be to add pulse width modulation via the 555. So like basically add a couple potentiometers, and then what I can do with that afterwards is I can, in effect, vary the, duty cycle of this. I have a PID controller for bullet casting, and my suspicions are that I can take this and then I can subsequently just measure the temperature output and see how the modulation's coming. Really, in theory, I should have a isolation transformer here. That is definitely not safe, and it's one of the reasons why I kind of disclaim myself here. This is not something I would put into production. This is strictly a proof of concept. Like I said, I make no claims to safety. Don't want to hear it in the comments. I mean, if you want to provide constructive ideas of what you could do to be safe in this case, that's cool. but no criticisms though. Yeah, I know what I'm doing here, and I know that it's not safe. Ooh, look at that. Looks good. All right, folks, we'll catch you on the next video. Bye.